Hello and welcome back to Kennel Corner Racing. What I'm going to do now is I'm going to demonstrate how we assemble a blaster bottom end here at Kennel Corner Racing. I'd like to dedicate this to Michael DuPont Jr., a very good friend, passed on to the greater beyond, but I learned more from that kid than anybody in my life, and fast boy and a big tragedy. But anyway, we're going to get on to business here. My platform for this is a blaster motor with a 240 cylinder. It's an LA sleeve cylinder that was installed here. This is not an LA sleeve cylinder. I mean, I bought a sleeve and I put it into a stock blaster cylinder. Wiseco +4 millimeter crankshaft, and we're going to do something a little different. I'm going to throw a 5 millimeter long rod in it. So I'll try and walk you through this and show you how we do it, and that's it. The best advice I can give you, whenever you're doing any of this, don't trust anything. Don't trust your parts, don't trust the new stuff. Anything you get, check it out, make sure it's right before you put it in your motor. That's going to prevent a lot of problems. We're going to show you a lot of stuff, and hopefully you learn something from this and see how we do it here at Kennel Corner Racing. Well, now that I got confidence in my cylinder, the next step is to throw the long rod in. This right here is a stock blaster rod. It's Pro X rod, and this is the 5 millimeter long rod. This thing is much more magnetic than this. I'm just kind of noticing that now. But this is 5 millimeters longer from center to center up here. I checked all of the other parts. The thrust washers are identical. The top end bearings are identical. The big end bearings are identical. The pins are different. The long one is the blaster. This is for a blaster crank. And this comes with the 5 millimeter long rod, which is not for a blaster crank, but real simple, the same diameter. What I'm going to do is I'm going to switch them out. So I'm going to use the blaster pin on the 5 millimeter long rod. Now when I do the math, here's some scribbling I got down. The stock rod, when I calculate everything center to center, it comes out to be 110.25 millimeters. Now that's a lesson to you. These rods are supposed to be 110 millimeters. This is about 10 thousandths. If you have a motor that's dialed in, this is what I call compounding tolerances. If you have a motor that's dialed in on a squish to be whatever you want to set it at, 40, 45, 50, whatever, and you throw this in, you're on the tight side, you just closed your squish band up 10 thousandths just by changing a rod. So that's definitely something to consider. With the 5 millimeter long rod, I did my calculations. This thing, if this is 110, it's a 5 millimeter longer rod, should be 115. It's 114.95 millimeters. That's very close. So I've got a difference, and I'm going to make this up in a base plate. I'm going to have to make a base plate for it of 187 thousandths minus my gasket thickness. I'm using the stock OEM Yamahas on the bottom and the top. So I'll tell you exactly what I'm going to do. I'm very happy with the motor. I'm not going to change the port timing whatsoever, and I am going to go up on the exhaust duration a little bit, but I'm just going to put a space. I'm going to throw the rod in and make a spacer plate. This minus the gasket, I think it's probably like 25 thousandths. So might be a little tricky cutting that, but we got ways of doing that, and that's where we are right now. So hopefully I get some warm weather here over the winter where I can get this put together. It's really not a big job. It's not rocket science, but I'll get this together, and hopefully over the next few weeks, and maybe get a warm day, or 45 degrees, I can definitely test it, and we'll see how it works. Okay, with the bottom end rebuild, the first thing we're going to do is we're going to do the crankshaft. We're going to put the 5 millimeter long rod in it, and the first problem that I found is because it's a 4 millimeter stroker, I built the engine for clearance from here to the sides of the cases when I trenched them. Lo and behold, and this is why you got to check everything, lo and behold, the bottom end of this rod, and this is the hot rods, and I took a hot rods out, it's a Wiseco crank, this was 20 thousandths bigger. So I got very innovative here. I'm not going to tell you how I did it. Sure, I'll tell you how I did it. I did it with a frickin' belt sander, but anyway, I had to cut the bottom part of the rod down so it would still clear my cases. The only option I had was to go back in, put the cases back into Bridgeport and trench them. I don't want to make those things any thinner than they already are. So we did that. I checked it, and I put it right at the money. And I'm very confident with this, and then I just went ahead and I polished it a little bit. These little gems, this is how I check to make sure that the big end and the small end are parallel with each other. This is just a really, really tight slip fit, and I use my dial calipers, and I check from here to here and here to here. That's telling me that my rod is straight. This rod is dead straight. I got confidence in this, so we're going to get ready and start prepping some more of the crankshaft. But that's the first thing I check on a motor when I'm rebuilding the crank, is make sure that the rod that I got is straight. What I got going on here is I got one of the flywheels off the crankshaft. This is a brand new Wiseco +4, and I ran it a little bit, but you know, I didn't machine this thing, but I'm about ready to. And if you watch this needle right here, what I'm doing is I'm checking the concentricity of the flywheel to the bearing surface. Now, this isn't going to be off a whole lot, but little things mean a lot. So what I'm doing here is just watch that needle as I turn it over. See it? This thing is out almost 4 thousandths. So what I'm going to do is I'm going to correct that. I'm going to take my lathe and I'm going to take a slice off of here. These are a little bit peculiar, these blaster crankshafts, because they have casting in here. I mean, if this was off, I could go ahead and cut this. I already checked this, and that's fine. So I'm just going to take it off of this and try and balance this crank a little bit more. Okay, I set what I think is going to clear this up, and the most important thing here is I'm not going to move this tool bit. Once I cut this, I'm going to pull this out, and then I'm going to go ahead and put the next web in, and hopefully it cleans up. And if it doesn't, then I'll just go in a little bit more and rechuck everything. And you know, absolutely, we're using a collar here. You can't use a three-jaw chuck on this. It's just not going to work. So a collar is going to hold it probably within a couple of tenths. So we're just going to go ahead and take a slice off of this. Things are pretty hard. You want to use a decent coolant on them. I'm using something called Rough Lick here. We use it for everything, and it works really well. That's about all there is to it. So as I spin this web, you know, I made contact everywhere, and I'm going to be true here, and that's going to balance this crank a little bit better, knock a little bit of the vibration out. I got the second side of my crankshaft in here, and we're going to do the same thing. We're just going to make sure that everything here is perfect to the bearing journal. So let the lathe off. Stuff is really hard. You got to cut this with carbide. And that's it. A couple of balanced flywheels.